If you tried using the debugger with brew code using objects, you'll find that it is not very easy to tell what's going on. So here's the binary tree code from the last part. If we try to debug this, we can see our local variables, which are objects, but they're just going to show us the object ID. So as we go through and create these node objects, we can see the object IDs, but we can't see the fields inside the object. We can't work through the tree that we're building, right? We can't start at the root and look at the left child of a node or the right child of a node. So it's almost impossible to tell what's going on. Our code is clearly working. We can step into these method calls. We can see that it's comparing this dot value to the value that's passed in, and we can infer what the value was by which way the if goes, but we still can't see exactly what values this is dealing with. We can go to the disassembly view, and we could get a little bit better idea of what's happening by looking at the stack. So we can step in here and we can see, okay, this is ID 1. And if we go get the value of the left field, then we're going to see that it was 2, right? So we can see as the VM opcodes are using the members what they are. But this is horribly painful. We don't want to deal with our code in this way. We want to see a nice display of the objects and the values inside of them. So that's the next step. To be able to do that, though, we need to track type information at runtime. Right now, our local variable array and our op stack just hold integers, and there's no way for our VM to know which integers represent object IDs and which ones are just values. So we're going to introduce a new class called value that will track the integer value of a piece of data and the data type of that value. So all of our data right now is integers. But now we're going to have a data type that tags along with the integer and tells us what it is. So it might be an int or it might be an object. I guess at this point, those are kind of the only values. We do have a null type. It could be a null value, which is an integer 0 that represents a pointer to an object that is not pointing to an object right now. So obstack and our local variable array are going to hold value objects, and then the debugger will be able to know what to do, and we'll be able to display the contents of our objects. So for this step, we're going to thread that value object through all of the existing code. So some of the existing code's been updated. Obstack is now a stack of value objects. Our local variable array is now an array of value objects, but the rest of the code has not been changed and doesn't compile right now. So for this step, you need to go look at those compile errors and then work through each one and figure out what to do there, right? So where we were just dealing with integers before, now we need to do the right thing with these value objects and make sure that that type information follows the values around. As we say, move a local to the stack, or we get something off the stack and store it in a field, any of these operations that we perform need to keep the data type along with the integer so that our debugger will be able to do the right thing.